Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Hello, dear students. I hope you're all doing well. This is Mr. Muad from the Easy Chemistry for All channel. Before we start our video today, please don't forget to share and subscribe to the channel and let us reach our first 1,000 subscriber. With your help, many students can hopefully benefit from these videos in their studies. Okay, so we are continuing our Inspire Chemistry journey with Module 14, Lesson 1, which talks about energy, الطاقة. And I'm sure that you covered energy before in physics and science and so on. Now we will repeat some of the things that you covered and we will go in depth to some other types. So, after this lesson, inshallah, what is expected from you to learn? So, you should read this sentence, and after this lesson, inshallah, you can or you should define energy, be able to define energy. So after this lesson, I can define energy, I can distinguish. So distinguish means تفرق, okay? You can distinguish between potential and kinetic energy. You can relate chemical potential energy to the heat lost or gained. Again, for point 3, we can relate chemical potential energy to the heat lost or gained in chemical reactions in general. And then finally, you should be able to calculate the amount of heat absorbed or released by substance as its temperature changes. Okay? All right. So I divided this video into 2 parts. We'll start with part 1. Okay? So in part 1, we will talk about the definition of energy, potential energy, and kinetic energy, and chemical potential energy, okay, or chemical potential in general. We'll state the law of conservation of energy, قانون حفظ الطاقة. We'll compare and contrast temperature and heat, درجة الحرارة والحرارة. Okay, what's the difference between both? شو الفرق ما بين الاثنين? Okay, so the big idea or the main idea of this lesson is that chemical reactions usually absorb تمتص or release تطلق energy. So التفاعلات الكيميائية تمتص أو تطلق الطاقة in general. Okay, I'll leave the link for this video for you down in the description section where you can watch a video on what is energy. Okay, so these are the new keywords for this lesson. So we are going to cover it inshallah during like throughout the video. Okay, so don't worry about it. These are the most important keywords in the lesson. So just to review some of the vocabulary, temperature is a measure of the average kinetic energy of the particles in a sample of matter. So if you have a sample, right, and you have 3 particles, for example, they have kinetic energies 1, 2, and 3. So temperature is going to be Ke1 plus Ke2 plus Ke3 over 3. It's the average of the kinetic energy of particles in a sample of matter. This is a very simplified version, but I'm just trying to explain to you the definition shown here. Okay? All right. So what is energy? What's the definition of energy? So energy, الطاقة, is the ability to do work or produce heat. المقدرة على عمل شغل أو أو إطلاق حرارة. Okay? أو تصنيع حرارة. All right? So what are the types or general types of energy? There are 2 basic forms. Okay? So the first one is potential energy, الطاقة الكامنة أو طاقة الوضع إذا أخذتوها في العلوم, or kinetic energy, which is طاقة الحركية. Very famous, right? These are the 2 types. So potential energy is energy due to the composition or position of an object. يعني طاقة الوضع من وين تيجي؟ من تكوين المجسم أو من موقع المجسم. Okay? Kinetic energy comes from the motion, من الحركة. Alright? For example here, water here has potential energy. but the water moving here has kinetic energy because it's moving. The water here has potential energy because it's not moving, but it has the ability to do work. Okay? If we open this, the potential energy will become kinetic energy, right? So these are some examples of kinetic energy and potential energies. Okay, so motion, electrical energy because of the moving current, sound waves. Okay, radiation energy, thermal energy or heat. Now potential energy can be gravitational potential energy, طاقة الوضع الجاذبية, electrical energy or electrical potential energy, chemical energies in the battery, elastic energy. I'm sure you studied the spring system in physics, all right? Remember the spring system, the K and the X, right, in the equation. I don't know if you remember this or not. And also nuclear energy. So all of these are potential energies, all right? And all of these are types of kinetic energies. So what are the two basic forms of energy? You're right. It is potential and kinetic, all right? These are the general basic forms of energy, all right? So chemical systems contain both kinetic energy and potential energy. So when we talk about chemistry or chemical reactions and so on, they contain both kinetic and potential energy, okay? So the kinetic energy of a substance is directly related to the constant random motion of its representative particles and it is proportional to the temperature. So the kinetic energy عندها علاقة طردية مع temperature of the particles اللي في المادة، الجسيمات الموجودة في المادة. Okay? The potential energy of a substance للمادة does not depend on the motion, no, depends on the composition. تعتمد على تكوين المادة من شو تتكون. What do we mean by composition؟ شو نقصد بتكوين؟ نقصد بها type of atoms، شو أنواع الذرات، number and type of chemical bonds، عدد وأنواع الروابط الكيميائية، ionic bond, covalent bond, metallic bond, and how the atoms are arranged، كيف الذرات منظمة في السبيس in 3D. Okay, شكلها. So these are some of the types of potential energy, and we will focus on chemical potential energy. الطاقة الكيميائية تكون مثلا موجودة في الطعام. Okay, so we'll focus about that in the next slides. All right. Now, before we go deep into that, I want to discuss the law of conservation of energy. Okay, قانون حفظ الطاقة. What does it say? It states that in any chemical reaction في أي تفاعل كيميائي أو تفاعل فيزيائي energy is neither created لا تتكون أو لا تدمر, okay, but can change from one form to another. الطاقة لا تفنى ولا تستحدث من الفراغ لكن تستطيع أن تتحول من شكل إلى آخر. Now this law here, هذا القانون اسمه, or it has the name of first law of thermodynamics. Okay, if you go to university, inshallah, and you choose to study engineering, especially mechanical engineering, then you will study a course called thermodynamics. Okay, and this is called the first law of thermodynamics. So what does that mean? For example, if you have a ball here, okay, now this ball has two types of energies, right? The potential energy and the kinetic energy. Now up here, the potential energy is the maximum because it's not moving, okay? As you go down, as the ball goes down, the kinetic energy increases because it's moving and the potential energy decreases. Before it reaches the ground, the potential energy becomes zero and the kinetic energy is maximum. But how do we represent that using numbers? So for example here, the potential energy plus kinetic energy is 10 joules. In here, it's also 10 joules, the sum, مجموعهم. In here, it's also 10 joules. So مجموعهم ما يتغير. But what's happening is that, for example, here it was 10, the potential energy here becomes 8 and the kinetic energy becomes 2 because the ball or the egg is moving. هني الكينيتيك انرجي تزيد تصير 4 والبوتنشال انرجي تصير 6 لكن مجموعهم دائما 10. Okay? So they can change from one form to another. The PE, some of it is changing to KE. لكن مجموعهم دائما ثابت. The sum is always constant. So what can you say about the value of KE plus PE in every position? Is it changing? No. Their sum is constant, does not change. And this is the first law of thermodynamics. All right? So these are some types of energy conversion. So for example, chemical energy can be transformed into mechanical, electrical into light, light into chemical, and so on. كيف إن الطاقة تتحول من شكل إلى آخر. Okay? I'll leave this EduShare link for you in the description. You can have a look at page 3 and also some of the videos that are in the other pages. I think it is very helpful if you are interested. Okay? All right. So, which of the following best describes the law of conservation of energy? I want you to stop the video here, try to answer, and come back to it. Okay. So, let's check each statement if it's correct or if it's related to the law of conservation of energy. It states that energy is neither created nor destroyed but can be transformed. يعني لا تفنى ولا تستحدث ولكن تستطيع أن تتحول من شكل إلى آخر. Yes, that is true. It is the first law of thermodynamics. Yeah, that is true. It states that energy cannot be converted. Converted means تتحول. نفس transform. From one form to another. This is wrong. Both A and B are true. Yeah, both A and B are correct. So the answer should be number D, or the letter D. Okay? Now, let's dig deep into the chemical potential energy. Okay? So the definition of chemical potential energy. طاقة الوضع الكيميائية. Okay? طاقة الوضع الكيميائية. For example, the one in a battery. So the chemical potential energy is energy stored in a substance because of its composition. So it's the energy that is coming from the composition من تكوين المادة نفسها. And what do we mean by composition? شو نقصد بالتكوين? We mean the type of atoms, like what are the elements in the substance, the number and type of chemical bonds, ionic, covalent, metallic, and how the atoms are arranged in space. كيفية توزيع أو ترتيب الذرات. Okay? So it's very important in chemical reactions, okay? Because sometimes in some chemical reactions, many chemical potential energy plays an important role and it transforms from one type to another, okay? And a famous example of that is combustion reaction. تفاعل الاحتراق اللي درستوه في صف 10. Okay, when you have a hydrocarbon with oxygen, okay, غاز الميثان اللي هو غاز الطبخ, it produces CO2 and H2O, and it produces energy. Okay, this is the reaction. All right, so it produces heat, حرارة. Where does that come from? الحرارة نوع من أنواع الطاقة. Where does it come from? It comes from this reaction, from the chemical potential energy, okay, of these substances, oxygen and methane. So this is the famous reaction, combustion reaction. If you have any hydrocarbon, CXHY plus O2, it gives me water, carbon dioxide, ثاني أكسيد الكربون, and heat and light, okay, which is fire. So which of the following best describes chemical potential energy? Again, you can go back, read the definition, or stop the video, and check your solution. So it is energy a substance has due to the charge of its electrons. We didn't talk about charge or electrons. It is energy stored in a substance because of its composition. Yes. It is energy a substance has due to the motion of particles. No. Motion means kinetic energy. It is energy stored in a substance due to its ability to undergo chemical reactions. You might think this is correct, but no. Because many substances go or undergo chemical reactions. The correct or precise solution is B, because this is what we talked about here. Okay? All right. So I want you to have a look here at this gas stove and this fire. Which of the following gas stoves is hot and why? So is this one hot or is it this one on the right? So of course, or if we think about this one, which is obviously hot, is energy or heat produced in this chemical reaction? And how do you feel it? So your answer would be yes, and we feel it through high temperature because the temperature here is super high, right? And you might get burnt if you put your hands close. So actually we have some sort of heat, حرارة هني, okay? And we have a chemical reaction, all right? So what is heat? الحرارة. We always say حرارة ودرجة حرارة. There is a difference, heat and temperature. So heat is actually a type of energy, okay, that is in the process of flowing from a warmer object to a cooler object. What does that mean? It means if you have cold water here and you put it down here, it will become hot, right? Why? Because energy is flowing from the fire to the cold water and then it will become hot water, صح? So this energy here, we call it heat. هذا هو التعريف. Okay? It's the energy in the process of flowing اللي هي تنتقل من الأجسام الساخنة إلى الأجسام الباردة. Alright? And there is a symbol for heat. الهيت عندها رمز. We use the symbol Q. Okay? So, if you see Q, it means it is heat, which is type of energy. Alright? So, that is all for part 1. We are going to start in part 2 now, inshallah. So, this is part 2 of the video. The learning objectives for this part is to perform interconversion, يعني تحويلات, okay, between units of temperature and heat. You will see what I mean by this. Describe the relationship between specific heat capacity, which is a key word that we will cover, of a substance and the resistance to change in temperature. Okay. For example, why does it take longer time for water to boil or to become hot compared to iron or copper? Okay. Calculate the amount of heat absorbed or released by a substance as its temperature changes. For example, if I have a substance and I have an initial temperature of 25 degrees Celsius and its temperature became 50 degrees Celsius. How much heat or energy did it absorb? Because it absorbed امتصت طاقة عشان ترتفع درجة حرارتها. So how much? So we will learn how to calculate that, okay? And now before we continue, I would like you to think about the units we use to measure heat, Q. So remember, heat is energy. Do you remember what is the major or main unit to measure energy? Exactly. It is the joule from your physics class, right? But we actually have the calorie, okay? We start here with the calorie because there are many units to measure heat in general. So we start with the calorie. And what is the definition of calorie? Calorie is the amount of energy required to raise the temperature of 1 gram of pure water by 1 degree Celsius. What is the meaning of this? Imagine I have pure water here, right? And I have 1 gram. جرام واحد من الماء النقي. حرارته كانت 25 degrees Celsius. The temperature was 25 degrees Celsius. Okay? Imagine that I heat it up, سخنته. Now the final temperature becomes 26 degrees Celsius. Okay? And it is 1 gram of pure water. So I added energy here, right? I added energy. It absorbed energy. How much? Actually, the amount of energy is 1 calorie. Why is it 1 calorie? Because that's the definition of calorie. Calorie is the amount of energy required to raise the temperature of 1 gram. So I have 1 gram of pure water and I raised the temperature by 1 degree Celsius. ارتفعت درجة الحرارة هنا بدرجة حرارة واحدة. So this energy here is 1 calorie. Alright? So that's the definition of calorie. Now, you will notice in food, if, for example, you are trying to do a workout or lose some weight or something, they will tell you, oh, you should try to control the calories that you eat, okay? You need to burn more calories, all right? So the content of food, that's called nutritional calorie. Notice that the C here is small and the C here is capital. So nutritional calorie. There's a difference, okay? So 1 nutritional calorie equals 1,000 calories with a small c, or 1 kilocalorie with a small c. What does that mean? So you know that 1,000 cal with small c is equal to 1 kilocal. Like 1,000 meter is equal to 1 kilometer. Remember that the kilo, right, which is K, means 1,000 or times 1,000, yeah? So you studied this long time ago. So when I say 1,000 calories, it means 1 kilocalorie. And this 1 kilocalorie is also equal to 1 nutritional calorie with the capital C. So just for you to learn the difference here, okay? This is just for you to learn the difference. So what do we use to measure heat? So joule is the international system of unit, or the main unit of heat and energy, as you know, as you studied from your physics classes, right? But we can convert or change joules to small calories, and then small calories to kilocalories, or capital calories with a capital C, right? So 1 joule is equal to 0.2390 calories, all right? Which of the following is the SI unit for energy and heat? So of course it's going to be the joule, right? We said that in this slide. So that's the main unit. So SI unit, SI means the main, okay? And the international system of units. It's what scientists agreed on when they share information, okay? All right, just to make sure we can, okay, yes, okay. Now let's go through a short example, okay? So a breakfast of cereal, cornflakes, okay, orange juice and milk might contain 230 nutritional calories. Express this energy in joules. So what did they give us? They give us the amount of energy in the breakfast, which is 230 calories. Notice here it's with the capital C. What do they want? They want the amount of energy in joules. So what we should do here, let me just skip this one. So known 230 calories with the capital C. The unknown, the energy in joules. We don't know it. Yeah? So actually, we need to go from calories to joules, right? From a capital C. Let's go back to the table here. Do we have this? No. We know that 1 small calorie is equal to 4.184 joules. Okay? Small calorie. So, and then the small calorie is related to the calorie of the capital C. So what do I mean by this? I mean that in order to go from capital calories to joules, I have to go first to small calories. So that's step number 1. Okay? And then step number 2 is to go from small calories to joules. So I know that 1 capital calorie is equal to 1000 small calories, right? So if I have 230 calories, how much is that in cal? So cross multiplication, الضرب التقاطعي نضرب هني ونقسم على 1. So we multiply 230 times 1000. It's equal to 123 small calorie. You see, we converted capital calories to small calories. Now, this is step number 1. Now, step number 2, we need to convert small calorie into joules, right? We know that 1 small calorie is equal to 4.184 joules. Now, if we have 230,000 calories, how much of that is in joules? Again, multiply and then divide. So it will be 230,000 times 4.184. That is equal to, let's use the calculator here, 230,123 times 4.184. It's going to be equal to 62320 joules. Okay, and that's our answer. So في الكتاب عندكم يختصر. Okay, sometimes يقربون. What does that mean? It means they do 9.6, so 1 decimal place, 2 3 1 2 3 4 5 decimal places, right? And then times 10 to the power of 5 joules. يختصرون يعني. They round up the numbers after 6. So both of the answers are correct. Okay. Now we are going to again. Sorry, before we continue, if you know these relationships, you can easily convert between joules and calories. Okay, you can use these conversion factors, or you can, like in the example written here, you can stop the video and have a look at it, or you can use cross multiplication, الضرب التقاطعي. For me, I prefer it this way because it's easier to understand. But again, you can always do the conversion factor. Just make sure that the unit that you want in the answer is up. The unit that you want in the answer is up. Okay? So, because you might say, teacher, which one do I use? Do I use this one or this one? هذه معكوسات صح? So, if you want your answer in joules, use the first one because joules is up. If you want your answer in small calorie, then use this one because calorie is up. Okay? And so on. You can apply this on these different conversion factors. Okay, now we go to the last part of this lesson, which talks about specific heat. So, what is the definition of specific heat? Okay? The specific heat of any substance is the amount of heat, يعني هي كمية الحرارة or the energy required to raise the temperature of 1 gram of that substance by 1 degree Celsius. Okay? Is this similar to a definition we saw before? Let's have a look. Calorie is defined as the amount of energy required to raise the temperature of 1 gram of pure water by 1 degree Celsius. So notice that here we are talking about pure water. الباقي كله نفسه. لكن إذا رجعنا للدefinition of specific heat, we are talking about any substance, أي مادة. Not just water, can be anything. Okay? So specific heat is the energy in joules that we need to raise the temperature by 1 degrees Celsius. Okay? So very important because different substances have different compositions لأن المواد في مواد تختلف في تكوينها. So كل مادة بتحتاج كمية طاقة مختلفة عشان نرفع حرارتها بدرجة واحدة. In other words, each substance has its own specific heat. Okay? Some objects require more heat than others to raise their temperature. For example, if I have substance X and Y, and the temperature here is 25 degrees Celsius, and here is 25 degrees Celsius, here I might need 1000 joules for the temperature to become 26. And here I might need 2500 joules for the temperature to become 26. هني درجة الحرارة ارتفعت درجة واحدة فيهم الاثنين. لكن كل مادة احتاجت كمية طاقة مختلفة. Why? Because they have different specific heat. Why? Because they have different compositions. عندهم تكوين مختلف. Okay? So this is what this slide is about. So these are the specific heats at 25 degrees Celsius for different substances. So كل مادة هاي الأرقام هني هي كمية الطاقة اللي نحتاجها عشان نرفع درجة حرارة جرام واحد من هاي المواد بمقدار درجة حرارة واحدة. Okay? So notice that water has the highest specific heat. معناها إنه أصعب مادة نقدر نرفع درجة حرارتها. Ethanol, this is liquid. Okay? This is water solid. هو ثلج. This is water gas, بخار الماء. Beryllium, magnesium, aluminum. So gold has the lowest specific heat. يعني يسخن بسرعة. طبعا احنا نعرف هذا الشيء لأنه المعادن موصلة جيدة للحرارة والكهرباء عشان شيء تسخن بسرعة. Okay? Because of its composition. بسبب تكوين المادة وتكوين الذرات. Alright? لا تحفظون هاي tables, but you need to understand them. So how can we understand them? Through this activity. Hopefully it will help you to understand what we mean. So this is this table here. Can you see it? This part. I'm zooming it here. So I'm asking you a question. Which substance will resist the change in temperature when heated more than the other? Concrete or silver? Concrete or silver, and why? So what do I mean by this question, guys? So I mean, I'm talking about these two substances, okay? إذا سخنا الكونكريت وسخنا الفضة، مين منهم درجة حرارتهم بترتفع يعني بسرعة أقل من الثاني؟ هذا معناه تقاوم الارتفاع في درجة الحرارة or resist the change in temperature. معناها واحدة منهم درجة حرارة بترتفع بسرعة أقل أو بشكل أبطأ من الثانية. Which one? So can you think using specific heat and what we talked about here? So the correct answer is going to be concrete. Why is that? Because the specific heat of concrete is higher, 0.84. So concrete needs 0.84 joules to heat up 1 gram by 1 degree Celsius. However, silver needs only 0.235 joules to heat up 1 gram by 1 degree Celsius. What do I mean by that? Imagine I have 1 gram of concrete and 1 gram of silver. Imagine if I add 0.84 joules here and 0.84 joules here. كم بترتفع درجة الحرارة هني من تعريف السبيسيفيك هيت؟ المفروض هني ترتفع درجة حرارة واحدة، صح؟ وفي السيلفر كم المفروض ترتفع؟ 0. هو يقول لك إذا ضفت 0.235 ترتفع درجة حرارة واحدة، بس أنا الحين ضايف أكثر، ضايف 0.84. فإذا قسمت 0.84 على 0.235 تقريبا نقول يطلع 4، صح؟ كأني ضفت هاي 4 مرات، يعني كأني زودت حرارته كم؟ 4 درجات. أي منهم بترتفع درجة حرارته بشكل أبطأ؟ concrete, because it has the highest specific heat. So when you see any question talking about resist درجة الحرارة, the one that will resist أو the temperature will change in a slow manner is going to be the one with the highest or bigger specific heat. Okay, so just remember that. Okay, now we learned about specific heat, we learned about heat, we learned about calorie, joules, and so on. And we have been talking about only 1 gram. 1 gram. Okay? What if I have more than that or less than that? So the specific heat of concrete, we said it's 0.84 joules per kilogram times degrees Celsius. So 1 gram of concrete absorbs 0.84 joules when its temperature increases by 1 degree Celsius. Again, هذا هو تعريف specific heat اللي هي كمية الطاقة الحرارية اللي يمتصها جرام واحد من المادة عشان ترتفع درجة الحرارة بمقدار درجة حرارة سيليزية واحدة. Okay? So imagine that the temperature of 5 kilograms of concrete increased by 6 degrees Celsius. How much heat did it absorb? تخيل لو عندي 5 كيلو جرام من الكونكريت والحرارة ارتفعت بمقدار 6. كم كمية الطاقة الحرارية اللي امتصتها؟ So again, I don't have 1 gram here, I have 5 kilograms, which is 5,000 grams. Also, the temperature did not increase by 1, it increased by 6. What should I do? So I know that if I have 1 gram, the temperature increased by 1 degree Celsius, right? And for that to happen, I need 0.84 joules. But now I have 5,000 grams and the temperature increased by 6 degrees Celsius. So how many joules did I need, or did the substance or concrete absorb? Okay, so that takes us to the following equation. Okay, the equation for calculating heat absorbed or release. المعادلة اللي تحسب لي كمية الطاقة الحرارية اللي امتصتها المادة أو فقدتها. Okay, so Q is heat in joules. C is the specific heat, alright? What do I mean by that? So C, specific heat, is these values, guys. Okay, هاي القيم على حسب المادة اللي يتكلم عليها في السؤال. Water, ethanol, beryllium, and so on. Okay, and M is the mass. Okay, M is going to be the mass of the sample in grams, بالgram, and delta T is going to be T final minus T initial. يعني درجة الحرارة الفرق في درجات الحرارة. Okay, so T final minus T initial أو مقدار الزيادة أو النقصان في درجة الحرارة. So Q equals C specific heat times M times delta T. So if we wanted to calculate Q here, it's going to be C times M times delta T. So what is delta T? It said increased by, يعني ارتفعت بمقدار كذا، يعني TF minus TI equals 6, and this is delta T. So it will be 6 times, what's the mass? 5,000 grams, What's this specific heat? This is the specific heat, 0.84. So if you multiply, it will give you an answer in joules. Okay? And this is how you calculate heat or Q. So which of the following equation is used to calculate heat? Of course, it's not H, it's Q, right? And I don't have delta H, I have delta T. So it's going to be Q equals C times M times delta T. Let's go and look at a question here. Okay? So in the construction of bridges and skyscrapers في بناء ناطحات السحاب والجسور, gaps must be left between adjoining steel beams and allow for the expansion and contraction of the metal due to heating and cooling. يخلون مسافات ما بين الأعمدة الحديدية اللي استخدموها في البناء عشان يكون في فرصة للتمدد والانكماش لما يكون الجو حار أو بارد. Okay? يقول لك تخيل لو or imagine if the temperature of a sample of iron with a mass of 10 grams changed from 50 to 25 with the release of 114 joules. What is the specific heat of iron? So the main part of the question starts from here. So let's highlight the most important things. Okay, give me the mass of iron. They said the temperature changed from 2, so from T initial to here is T final with a release of 114 joules. So this is Q and this is M. So I have TFTI, M, Q. What is the specific heat? So they want C. So this is what we have, guys, here. Okay, mass of iron, we have the energy released, which is Q, we have Ti and Tf, and they want the specific heat اللي هي C. Okay, in the unit joules per gram times degrees Celsius. So from here we can find delta T, which is Tf minus Ti, صح؟ اللي هي 25 ناقص 50.4 اللي هي تساوي ناقص 25.4 degrees Celsius. Now guys, the energy is released معناها فقدت. Okay, sorry, energy released معناها فقدت. Okay, معناها المفروض ان الكيو تكون بالنيجاتيف لانها فقدت مش absorbed لم تكتسب. So if this is minus and this is minus وضربناهم او قسمناهم في بعض it will cancel فبتعطينا C positive. لكن هو عندكم في مثال الكتاب already ما استخدم الماينس هني وخلى هاي بالموجب وهاي بالموجب عادي. المهم قيمة السي دائما positive, always positive. Just make sure that you know that, okay? So they calculated delta T, okay? So they did 50.4 minus 25. So what they should have done is to tell you about that, but it doesn't matter. Even if this one is positive, this one will also be positive and it doesn't matter. The most important thing is that you write your equation Q equals C times M times delta T. You want C, صح؟ فنقسم هنا على M ضرب delta T ونقسم هنا على M ضرب delta T. هاي تروح مع هاي وهاي تروح مع هاي. So my final equation becomes C equals Q over M times delta T. Now put the numbers. You have the numbers of Q, you have delta T, and you have M. So if you put the numbers, okay, then your answer should be 0.449 joules over gram times Celsius. Now, let's make sure that we are talking about iron اللي هو الحديد 0.449. خلينا نرجع للتيبل ونشوف if we have that. Iron specific heat is 0.449 معناها حساباتنا كانت صح. لأن هاي specific heat اللي هي قيم السي. Okay. Yes. Right? So again, this is another example for you guys, which you can have a look at. Okay? But the question here is about how much heat has been absorbed. So يقول لك طلع لي Q. So you have the known values here. Okay, you find delta T, you write the equation, and then you find your answer in joules. So you can stop the video here, have a look at this question, try it first on your own, and then check your solution down here. All right? And that's the end of our section. So what did we cover? We learned that energy is the capacity or ability to do work or produce heat. Chemical potential energy is the energy stored in the chemical bonds of a substance. Due to these bonds, the types of atoms and how atoms and molecules are arranged. Chemical potential energy is released or absorbed as heat اللي هي Q during chemical processes or reactions. Okay? So thank you very much for watching this video. I hope it was beneficial for you guys. Again, if you have any question or any comment, please use the comment section, or you can contact me, as you can see here. And again, guys, please try to share and subscribe to the channel. Share it with your friends again, and let's try and reach our first 1,000 subscriber. Okay? I wish you the best of luck and see you in the next video, inshallah. All the best.